Hey, yo, what's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are continuing with day 4 of 5 on the SAT Massive Cram Session Review, which I'm really excited about. And let's see here. So again, this has been a blast for me. It's been a blast to see how everybody has been jumping on and participating and asking questions. I know I'm a little behind on getting back and answering some of your guys' questions, but I'm going to answer everything today that's kind of in the log as soon as we get offline today. If this is your first time joining, look, at the end of the day, what these sessions are all about is watching me do tests in real time under real-time circumstances and showing you how I reason and how I think so you can adopt those strategies into your own test-taking protocol. Now, I myself, again, have gotten a perfect 800 on the math on a real SAT. Of course, I practice with these problems all the time. I'm pretty good with them. That being said, you'll see, like, I'm taking these for real right now. So you never know. Sometimes I'm not like sitting down beforehand and going through all the questions and making sure I know the answers. I'm not doing that. I want you to experience an authentic time through the actual SAT where I'm thinking and problem solving in real time, so you can see what it's all about and see that it's the real deal. All right, so what we're gonna do today is test 4, and I've already done tests 1 through 3. So again, I'm gonna be doing first the calculator section. First the non-calculator section. Then I'll answer questions. Then I'll do the calculator section, break, answer questions, and then we'll conclude for today. And tomorrow's gonna be special because not only am I going to do this entire test 5, but I'm also going to be giving some really important tips about strategy that you can implement the day of. So for you guys who are taking the test on Saturday, that's really who this whole thing is for. But if you're taking it in the future too, definitely watch and glean what you can out of this whole experience. So okay, let me just get this test set up and we will begin. I'm kind of skipping through the reading section. Let's go. I've been talking so much the last few days because I've been doing this hour and a half plus teaching 4 to 6 hours every day. My voice is starting to hurt, but it's all good. Okay, here we go. Math, no calculator. We're good here. All right. Let's do it. Which of the following expressions equal to 0 for some value of x? Okay, anything where we're adding 1 to something in absolute value is not going to fly because this can never be negative. So this is the only one. We'd plug in 2, let's say, and we'll get absolute value of 1 minus 1, which is 0. Next, f of x equals 3x plus b. The function above b is a constant if f of 6 equals 7. So they're telling us to plug in 6 right off the bat. So the function value equals 7 when x equals 6. So let's cross simplify. 3, 1, multiply cross 7 equals 9 plus b. Subtract 9, b equals negative 2. And so now if I know that b equals negative 2, what's the function value when we've got negative 2 in for x? And I know now that b is negative 2. So we got negative 2 times, so these cancel out, makes this negative. So this is negative 3 minus 2, which is negative 5. Next, x over y equals 6. 4y plus 1, parentheses, equals x. We need a solution to this, so I'm going to do a little substitution here. I'm going to substitute this in for x up top, so because that equals x down here. So I got 4y plus, I'm going to distribute this 4y plus 4 over y equals 6. Multiply both sides by y. We get 4y plus 4 equals 6y. Subtract 4y. Subtract 4y. We got 2y equals 4. Divide by 2. And we got y equals 2. Next, f of negative 3x. So all we're doing is we're plugging in negative 3x in for f of x. So what does that mean? That means that the negative 3x is replacing x. So everywhere where we had an x, we've now got negative 3x. Plug it in there. Negative 2 times negative 3 is positive 6x plus 5. And there we go. Next, which of the following is equivalent? Remember, when we see that phrase, what we're talking about really is simplification. So in this case, we've got a quadratic factored, so we just need to FOIL. So I'm going to FOIL the inside first. Okay, 2x times 4x is 8x squared plus 2x plus 4x plus 1, right? 2x, 4x, 1. These guys combine, 8x squared plus 6x plus 1 times 3, and then distribute that, and we get 24x squared plus 18x plus 3. Oh, I could have, and to be honest, I could have guessed that, but we'll talk about that later. All right, which of the following must be true? So we're talking again about equivalent expressions, and what it looks like, let me see if I can do a shortcut here. A minus B equals 11 over 7. Okay, I'm not sure. So what I'm going to do is I'm just going to cross multiply and see what happens. So this is a case where I sincerely not sure what to do. So I'm just following my own advice of just do something and start simplifying. So now I have 7A minus 7B equals 3B. I'm going to get the B's together by, add 7b to both sides. So I got 7a equals 10b. All right, I think I know the answer now. Now I'm going to divide both sides by b. And then, so now I got 7a over b equals 10. Now I'm going to divide both sides by 7. And then I got a over b equals 10 over 7. Boom. Next, while preparing to run a marathon, Amelia created a training schedule in which the distance of her longest run every week increased by a constant amount. If Amelia's training schedule requires that her longest run in week 4 is a distance of 8 miles, and her longest run in week 16 is a distance of 26 miles, which of the following best describes how the distance Amelia runs changes between week 4 and week 16? So over 12 weeks, she's increasing by 18 miles, okay? So every week, so if we kind of simplify this down, divide both by 6, we get 2 over 3. So every 2 weeks, she's increasing by 3 miles, or every 1 week, she's increasing by 1.5 miles, something like that. As long as I got these numbers in here correctly, right? Week 4 is 8, week 16 is, yeah. So Amelia increases the distance of her longest run by 0.5 miles each week. No, because this is week. This is miles. 2 miles each week. No. Amelia increases the distance of her longest run by 2 miles every 3 weeks. No. Amelia increases the distance of her longest run by 1.5 miles each week. That's what we got. Cool. Next, which of the following equations represents a line parallel to this? Well, anything where we're going to have a slope of -3, right? Because parallel means same slope but different y-intercept. Now, these aren't in slope-intercept form, so that's an issue. But I can quickly see that this one is going to have a slope of -3 because I'm going to subtract 6x from both sides and divide by 2. That's a slope of -3, so it's probably a, but let's just prove it. 6x plus 2y equals 15. Subtract 6x, subtract 6x. 2y equals -6x plus 15. Divide everything by 2. And we get y equals -3x plus 7.5. Different y-intercept, same slope, parallel, boom. Next is a. They're saying a equals 2, so we plug 2 in for a and then solve for x. So I'm going to square both sides to free this from being squared, and that's x minus 2 equals, this is foiled out, becomes x squared minus 4x plus 16. If you're not sure how I did that, this is really x minus 4 times x minus 4, and then we FOIL. Okay, and then these combine to -8x. Okay, now let's get everything to, it's a quadratic, so we're going to set everything equal to 0. So it's x squared. I'm going to subtract x from both sides, minus 9x. I'm going to add 2 to both sides, plus 18 equals 0. And then I'm going to FOIL. So what multiplies to 18 and adds to -9? That's -3 and -6. So my solutions are where this goes to 0, which is x equals 3, and 6. But we're not done. So you might think it's A, but we got to test it out by plugging it into the original equation. So let me make some room, because this is how you can get tricked sometimes. So it's square root of x minus 2 equals x minus 4. So when we have a 6 and we plug it in, 6 minus 2 is square root of 4, which is 2. 6 minus 4 is 2. So that one checks out. 6 is good. What about 3? 3, we get 3 minus 2, which is 1. Square root of 1 is 1, equals 3 minus 4, which is negative 1. So these are not equal. So the 3 is no good. We cross that out. So it's just 6. T plus 5t minus 5 equals 10. What is the value of t? All right. Multiply both sides by t minus 5. 10, right? That kind of goes away here and then comes here. T plus 5 equals 10t minus 50. Consolidate the variables. Minus t, add 50, and we get 9t equals 55. Whoop. That doesn't divide nicely, but that's okay. Divide both sides by 9, and t equals 55 over 9. Ah, cool. Next, 11. How many ordered pairs satisfy the system of equations above? Well, I guess what we could do, here's what we can do. We don't actually have to solve this. I'm gonna kind of put these both in slope-intercept form. So this one is a line, so it's x equals, or this one is a line, this one's not. 2y plus 5, because this one's going to be an x squared. So I'm going to flip this like this. This becomes 2y equals x minus 5. This is y equals x over 2 minus 5 over 2. Okay, so it's a line, positive slope of 1/2, because this is really 1/2 x. And then this one is y equals 2x squared plus 18 minus 3 plus 15x minus 27. Okay, when you FOIL it all out, this is what you get. Okay, what I can tell here, and then I'm going to put this into vertex form. So again, I'm not trying to solve this. I'm just trying to get a picture in my mind of what this looks like. And I think that alone will tell me how many solutions there are. Actually, vertex form is going to be kind of a pain. Okay, let's do it a different way. Actually, this is good. We don't need to modify this. I rescind that statement because this tells me my two x-intercepts. So I know my x-intercepts are going to occur where values of x are going to set y equal to 0. That's going to be for -9. So let's say -9 is right here. And this one is going to be for 3 over 2, where x equals 3 over 2, right? So let's say that's 1. Here's 3 over 2. And then my vertex will be somewhere down here, but it's okay. It doesn't matter so much. So boom, like this, and like this. Now this one will be a slope of 1/2, which is kind of like this or something. And y-intercept of -5 over 2. So -5 over 2 is like -2.5 to somewhere like here. And then it kind of goes up like this. You know what? I'm going to take this back because actually this gives me a rough idea. It could be like 1 or 2, but that's too vague. I think I am going to have to set these equal to each other. So solutions, we're going to set them equal to each other. And I'm going to basically substitute this in for my y value and set it equal to this. All right, sorry guys, this is really taking way too long. 2x squared plus 15x minus 27. Okay, and then I'm going to multiply everything by 2 to get rid of this, and we got x minus 5, that gets rid of those, equals 4x squared plus 30x minus 27. And then I'm going to combine my like terms, so I got 4x squared plus 29x, subtract x from both sides, add 5 to this is minus 22 equals 0. And then, and then we just take the discriminants, because it's saying how many solutions are there. So the discriminant is b squared minus 4 times a times c, which is -22. Okay, I get it now. So this is like pretty big. 29 times 29 is 1, 8, 18, 26, 0, 18, 4, 5. So it's 1, 4, 8. So it's 8, 4, 1. minus, actually it's plus whatever. This is going to be some positive number. So the discriminant is positive. Let's see if I can do it really quickly. 88 times 4 is something in the 300s. 300s approximately. And the bottom line is when the discriminant's positive, we know we have two solutions. If it were 0, we'd have one solution. Right? I think I'm doing this correctly. And then if it were 0, would have one solution. If it were negative, it had no solutions. Okay, I think this is maybe right. Let's move on from this. I don't know if I approached that exactly right. I'll go back to it if I have time. So that's number 11. Ken and Paul each ordered a sandwich at a restaurant. The price of Ken's sandwich was X dollars, and the price of Paul's sandwich was $1 more than the price of Ken's sandwich. So if Ken and Paul, so price of Ken's was X, and the price of Paul's was X plus 1. If Ken and Paul split the cost of the sandwiches evenly, okay, so they did X plus 1 divided by 2. They split it evenly and paid a 20% tip. Which is dollars each of them paid. So then it's this plus a 20% tip, which means we multiply it by 1.2. All right, so let's get this down. 2x plus 1 over 2 times 1.2. So this multiplies in here, and then it's 2.4x plus 1.2 over 2, which comes out to 1.2x plus 0.6, divided both by 2. Functions f and g are defined by this and this in graphed and xy plane. The graphs of f and g intersect at points k0 and negative k0. What is the value of k? Okay, so they intersect, meaning these two are equal at those 2 points, and then we've got to find k and negative 0. Or k and negative k or something. So now we got to solve this. So I'm going to add, this is where they are equal. So I'm going to isolate x. We got 16x squared because I'm adding 8x squared to both sides equals 4. Then I'm going to divide both sides by 16. I get x squared equals 4 over 16, or 1/4. Square root of x, or square root of x squared is x equals 1/2, plus or minus. So they intersect, and they intersect at the origin. I'm sorry, on the x-axis. So both of them have zeros, right? And it's going to be positive 1/2 and negative 1/2, like this. So k is 1/2. All right, next. Anytime you see an I in the bottom and they're asking you to simplify or whatever, we don't want an I in the bottom. So first step, we need to get rid of that by multiplying by the complex conjugate of the denominator, which is just where you reverse this to a plus. And you'll see why this works really nicely in a second. So if we multiply and FOIL, 3 times 3 is 9. Then we get 6i plus negative 6i. And those cancel out. And then minus 4i squared, but I squared is negative 1, so it's plus 4. So our denominator is just 13. And then our numerator becomes 24 plus 16i minus 3i minus 2i squared, which is plus 2. So the negative and a negative cancel out. Combine like terms, we get 26, right? 24 plus 2 is 26, plus 13i over 13. Divide these both by 13, I get 2 plus I. And it's saying what's A? A is the integer up front here, which in this case is 2. And the quadratic equation above k and p are constants. So what are the solutions for x? Okay. So let's set everything equal to 0. Oops. Minus k over 2x minus 2p equals 0. K and p are constants. Excuse me. Let's multiply everything by 2 to get rid of this fraction. So it's 2x squared minus kx minus 4p equals 0. And then let's take the quadratic. Quadratic is negative b, which is k, plus or minus square root of b squared, which is k squared, minus 4 times a times c. So 4 times 2 times negative 4 over 2a. 2 times a is 4. Okay. This become negative and a negative become positive. 4 times 2 is 8 times 32. So k plus or minus square root of, well, k squared plus 32 all over 4. Okay. So that's the solution. Now let's see which one of these is it. This is the only one I forgot the p. Oh yeah, because this is a whole constant. Sorry, not a variable. So it's 32p. And I guess it's this, but wait a minute. That's k over 2. It should be k over 4. Oh, here we go. K over 4 plus or minus k squared plus 32p over 4b. All right, 7 minutes left. Let's keep going. Now these should get easier for a time being before it gets harder. Jim has a triangular shelf system that attaches to a shower head. The total height of the system is 18 inches. There are 3 parallel shelves. What is the maximum height in inches of a shampoo bottle that can stand upright in the middle shelf? Okay. All right, so this is 18. So this is probably proportionate. So if this is 2, 3, 1, this is probably 2, 3, 1. So 2x plus 3x plus 1x equals 18, right? So this height, this height, this height, that's what I'm representing here. So 6x equals 18, therefore x equals 3. Therefore, this height is 9 inches. Okay? Because this proportionality is linked to this proportionality, which is why I can split this up in that way. In the triangle above, sine of x is 0.6. They're equal, okay? Sine of x equals the cosine of y. That's just a theorem. So if sine of x is 0.6, cosine of y is 0.6. For what real value of x is the equation above true? Okay, we got x. Oh, this is factoring by grouping, I think. 5x squared, I think, plus 2x minus 10 equals 0. So factoring by grouping, I pair these guys off and pair these guys off. This one I'll factor out at x squared, and I got x minus 5 left in here, plus here I'll pull out a 2. X minus 5, yeah, it works. This is how we know it worked. And then I factor this out of both of these two, and I get x minus 5 times x squared plus 2 equals 0. So one solution is 5, right? The other one would be, oh yeah, this would be imaginary. So 5. This would set the whole thing to 0. Next, what is the value of x? We need to solve a system of equations. Plus 3y equals 15. Okay, easy thing is to eliminate the x's, but we actually want x, we don't want y, so let's eliminate the y's. I'm going to multiply this one by negative 4 and this one by 3. Just save us time. 9x is the top one, plus 12y equals 60. The bottom one is negative 24x minus 12y equals negative 60. Let's combine them. These cancel out to 0. These cancel out to 0. And this becomes negative 33x. But then, of course, x just equals 0. If x equals 0, y equals 5, x equals 0, y. Okay, so 0, 5. So x equals 0. The mesosphere is the layer of Earth's atmosphere between 50 and 85. 50 and 85. Above the Earth's surface. Oh, let's do it the other way. Okay, 85. The temperature in the mesosphere is negative 5 degrees Celsius. At a distance of 50, it's negative 5. At a distance of 80, the temperature is negative 80. Okay? For every additional 10 kilometers from Earth's surface, the temperature in the mesosphere decreases by K Celsius. What is K? All right. So when it goes up by 30, okay, we go down by negative 75. So 30, a change in 30 is a change of negative 75. So we want to know what happens when we have a change of 10. Well, look, this is really nice. I can divide the top and bottom by 3. I get every 10 meters, it changes by negative 25. Decrease, but they're saying decreases by, so we just make it a positive 25. I think that's right. So let me just double check. 50 is negative 5. 60, it's negative 30. 7, it's negative 55. 70, 80, then it would be negative 80, 55. Yeah, okay. Okay, so that's cool. I feel pretty good about that. Let's go to the first skipped one. And then, did I skip this? Wait a minute. I thought I answered that. Okay. I'm pretty sure that was what we chose, B. Uh-oh. Go back to question 1. Where was that crazy one? This one. All right, it was question 11. So let's double check this really quickly. So I kind of substituted in and I solved and I got, I just used the discriminant assuming that gave me 2 solutions. Actually, I think that's right, to be honest. I think that's the best way to do it. So let's do it one more time. And this time I'm just going to do it a little differently. I'm going to say x equals, I'm going to plug in this whole thing for y, because it says y equals this. 2 times 2x minus 3, x plus 9 plus 5. Okay, and this says x equals, if we FOIL this, it becomes 2x squared. I think it was 15x, 18 minus 3, 15x minus 27 plus 5. X equals 4x squared plus 30x minus 54 plus 5. Combine this x and move the x over, actually. So it's 4x squared minus or plus 29x minus 49. Okay, and the last time I did the discriminant, so I said negative b, which is negative 29. No. The discriminant is b squared, 29 squared, minus 4 times a times c. Since this whole value here is positive, I feel like I got a different set of numbers before, but this whole value here is positive anyways, right? So if this thing is positive, it's a positive plus a positive. It's a positive discriminant, which means we should have 2 solutions. So I think that we're good here. Okay, let's review it. Come on, baby. Yeah. All right, so all right. Let's go and check the questions. What do we got? So what's up, guys? How many years is the SAT score valid? I don't actually know for sure. I remember hearing somewhere I think it's 5 years, but I'm not positive about that. So I would definitely look that up. I can look it up at the end of this section. We could probably figure it out. Hey, so to Hamza, so sorry, when I'm taking this timed, I'm not actually checking the chat until I finish a section because I'm doing it under time circumstances. So that's why now I'm taking this time. So yes, I do check the chat. So no, I'm going to come back. So you want me to do 6. Let's see here. Okay, here we go. Number 6. What was your, hold on, what was your suggestion? You said to plug in, hold on. You said plug in a value for A and B, plug and chug. Yeah, I mean, you can always do that. Let me see if that would have been. Yeah, I mean, I'm not a huge fan of that here because let me think about it for a second. 6, so B would be 7, and then, oh, I get what you're saying, and then A has to be 10. Oh, I see what you're saying. That's way faster. That's a good suggestion because we know just from looking at the first example right up here that B has to equal 7, therefore A has to equal 10. So that's actually pretty smart. That would have definitely saved time from the way that I did it. So very good observation there. Tamid, dude, why you gotta hate? Even if they are, if you're cramming, you're cramming. Yeah, you should obviously spend as much time as you can, but why even be negative like that? Okay, so then Mason, should I repeat all the tests over again? I'm through the first time. Yeah, like, if you have time, I always say the more times you can practice and go through practice material, I'd say that's awesome. If you're looking for additional practice problems that are new to you since you've already done these, again, I have an SAT course that's for sale that has 700 additional practice problems plus video explanations. You can check that in the link below, and you'll get a 75% discount if you click it through my link. And then for you can also go to Kaplan. You can go to, there's all sorts of companies that have additional practice problems. So I would hit it as hard as you can. Friday's the day where you shouldn't go crazy, because then you're taking it the next day. And then Adam can't, sorry, I can't read the very bottom. It says usually write stuff out for our, okay, well, I will come back to that. I can't read it fully right now. So again, guys, now we're going to jump into the calculator section. Get my calculator ready here. And, whoops. Okay, 55 minutes. Let's do it. The monthly membership fee for an online television and movie service is $9.80. The cost of viewing the television shows online is included in the membership fee, but there's an additional fee of $1.50 per each movie. For 1 month, Jill's membership and rental fees were $12.80. Look how I'm just translating this to a sentence. How many movies did she rent? Let's solve for X. This is 150X equals $3 divided by 150. 2 movies. Whoops. Next. One of the requirements for becoming a court reporter is the ability to type 225 words per minute. Donald can currently type 180 words per minute, and he believes that with practice he can increase his typing speed by 5 words per minute each month. So he's at 180, and he goes adding on 5 words per minute each month. Which of the following represents the number of words per minute that Donald believes he'll be able to type in M months? Right here. He's at 180 plus 5M, 5 words more per month. They changed the order, but that's fine. Oh, wait. What? Oh, no. That's totally wrong. It's 180 plus 5M. Okay. If a 3-pound pizza is sliced in half, and each half is sliced into thirds, okay. What is the weight in ounces of each slice? Okay, so 3 pounds, so this is 1.5, and then 1.5 divided by 3 is 0.5. So each slice is 0.5 pounds, or half a pound. 1 pound is 16 ounces, half a pound is 8 ounces. Nick surveyed a random sample of the freshman class of his high school to determine whether the fall festival should be held in October or November. Of the 90 students surveyed, 25.6% preferred October. Based on the information, how many students in the entire 225-person class would prefer to have it in October? So it's 25.6 times 225. But in the 0.256, we converted to the decimal equivalent, times 225 equals 57.6, so it's closest to 70. Let's just make sure. All right, got this right. Yes. Okay, next. The density of an object is equal to the mass of the object divided by the volume of the object. So density equals mass divided by volume. What is the volume in milliliters of an object with a mass of 24 grams and a density of 3 grams? We're trying to solve for volume, so I'm going to multiply V over here and then divide both sides by 3, and it's 8. Right? Yeah. Next, last week Raul worked 11 more hours than Angelina. So Angelica. If they worked a combined total of 59 hours, system of equations, how many did Angelica work? So let's plug in this for R. A plus 11 plus A equals 59. 2A plus 11 equals 59. 2A equals 70. Divide by 2, divide by 2. A equals 35. The table to the left represents the 50 movies that had the greatest ticket sales in 2012, categorized by movie type and motion picture. What proportion of the movies are comedies with a PG-13 rating? Okay, total is 50 movies. Comedies with a PG-13 rating is 4 out of 50, which is 2 out of 25. Next is line L in the XY plane. Contains points from each quadrant, but no points in quadrant 1. Actually, wait, it can't have a positive slope then. So this is what it would look like if this is my x-axis and this is my y-axis. And it's got no points in quadrant 1. It's got to be a negative slope because otherwise it'll eventually hit this quadrant. And so, which of the following must be true? Yep, it's negative, this one. The table above, the table here, let me copy this. Okay, so the table, the table above shows the number of registered voters in 2012 in thousands in 4 geographic regions and 5 age groups. Based on the table, if a registered voter was 18 to 44 years old in 2012, 18 to 44 here, is chosen at random, which of the following is close to the probability that the registered voter was from the Midwest? So we're choosing somebody from random out of this group, and what's the probability they're from the Midwest? So it's 3, 4, 5, 3 out of this total, not that total. Right? Yeah, 14,766. So let's do this in the calculator. 3, 4, 3, 4, 3, 5. Oh, so 3, 4, 5, it doesn't matter, but 3, 4, 5, 3 divided by 14,766. And that's my probability. We just leave it like that, 0.2338. I guess that's the closest, but it's not, it's off by 0.02. Just make sure I read it right. 1844, 24. Oh, that's why I misread it. 18 to 44. Whoops. So that's this entire region. That's this entire region. So what is the probability of the registered voters from the Midwest? Okay, that's close. So I got to add these. So it's like this, 11, 2, 3, 7, 47, 8, 9, 6. So it's 3, 4, 5, 3. 3, 4, 5, 3 plus 11, 2, 3, 7 equals, divided by 14, 7, 6, 6 plus 4, 7, 8, 9, 6 equals. All right, there we go. Wait, what? It's almost the same. 0.234. So it's still like 0.25. Yeah, it's about 0.25, and that is also about 0.25. So it doesn't really change anything. Okay, that's interesting. All right, next, what is the life expectancy in years of the animal that has the longest gestation period? Okay, so gestation period is here. Here's the longest one. Life expectancy is 3. Of the label points, which animal represents the animal for which the ratio of life expectancy to gestation is greatest? So life expectancy to gestation is greatest. Of A, B, C, or D. So this one, so let's see. A is 7 over like 22. This one is 8 over 43. I'm already assuming it's this. That one, C is definitely, B is better than C, so C is out. And then D is 10 over 52. So it's like 1/5. This is like 1/3. So A. The graph of function f is intersects of x minus of -3, which means this is a factor or whatever. -1, which means we do x minus -1, which is x plus 1, and +1, which is x minus 1. Which of the following could define f? So x plus 3, this one, this one, this one. Boom, right here. The population of mosquitoes in a swamp is estimated over the course of 20 weeks as shown in the table. Which of the following best describes the relationship between time and the estimated population of mosquitoes during the 20 weeks? Definitely increasing. It's not increasing linearly. It's increasing. Wait. Hold on. Maybe it is. 900 over 5, 9,000 over... No, sorry. It's increasing exponentially. Because linearly, it's like this goes up by 5, this should go up by 900. This goes up by 5, should go by 900 again. But no, now it goes up by 9,000. So it's going to be like, you know, if we graphed it, it'd be like this, then like this, then like this. So that's exponential. Okay, the expression above gives the amount of money in dollars generated in a year by a $1,000 bank deposit. That's this value. That pays interest rate of R compounded monthly. Well, that's why this is 12. Which of the following expressions shows how much additional money is generated at an interest rate of 5% versus 3%? So currently it's 3 over this, and it becomes the difference of 5 and 3. It's like this one. Right? Because it's really an additional 2%. Oh, wait. Wait a minute. This is at my 5%. Oh, wait. I rushed to that one. It's this one. This is how much this is fail proof. I mean, this could be it, but now this actually is wrong. This one is telling me here is how much money I make at 5%. Here's how much money I make at 3%, and the difference. This is how much money I'd make at 2%, which is not necessarily the difference. In fact, yeah, it's going to be more than a 2% interest rate. So it's D. Which of the following scatter plots shows a relationship that is appropriately modeled with the equation this? All right, so this is an exponential equation. A is positive, and it's going to go, but B is negative. Oh, wait, that's different. Okay. So if A is positive, that means B is a negative exponent, means it goes under here like this. Okay? And otherwise, if it were positive, it would go up like this. But now it's like what's happening is as this exponent goes up, this is actually, and as the exponent's really low and this value is low, it's going to be high. And then as the exponent increases, it's going to get closer and closer to 0. So it's going to be like that. Which is B. And see here, this would be if B were positive. Mr. Martins' building is a concrete patio in his backyard. Is building a concrete patio and decided where to buy the materials and rent the tools. The table shows the material cost and the daily rental cost for 3 different stores. All right. The total cost Y for buying the materials and renting the tools in terms of number of days X is given by this. Y equals M plus W plus K times X. For what number of days X will the total cost of buying the materials and renting the tools from store B be less than or equal to the total cost of renting and buying from store A? Okay. So we've got store B, so it's 600 plus W is weeks, which is 25, plus 80 times X. When is store B less than or equal to store A? Okay. So then we do 750 plus 15 plus 65 X. Okay. So this becomes 600 plus, now let me write it down here. 600 plus 105x is less than or equal to 750 plus 80x. Okay, let's subtract the x's over here. 105 minus 80 is 25x. Subtract 600 is less than or equal to 150. Divide both by 25. X is less than or equal to 6. So 6 days. And then next is the relationship between total cost of buying materials and renting the tools at store C and the number of days X. Wait, the relationship between total cost Y of buying the materials and renting the tools at store E and the number of days X. For which of the following tools are rented is graphed in the XY plane. Oh, what does the slope of the line represent? Got it. Okay, that was really confusing wording. So this is for store C. Oh, and the slope is just the incremental cost per week. That's it, or per day. The total daily, it's daily rental costs. Not total daily costs, because this is also part of that daily cost, right? Total. Yeah, because if we wanted the total daily cost, we'd have to still factor this in and divide by the days and everything. And then, yeah, so it's the total, well, how much we're spending every day to rent the tools. This is just the materials that we have to buy up front. Okay, next. Jim has identical drinking glasses, each in the shape of a right circular cylinder. That's like Coke can, right? Internal diameter of 3 inches. That's a cross like that. He pours milk from a gallon jug into each glass until it's full. Okay. And then if the height of the milk in each glass is 6 inches, what is the largest number of full milk glasses that he can pour from 1 gallon of milk? And then it gives us the equivalency. All right, what's the volume in here? It's 2 pi r squared times height. But then there's 2 of them, so it's times 2. Okay, now let's plug it in. So this becomes 4 pi. R is 1.5. It's the radius. So it's half of the diameter squared times height, which is 6. 1.5 squared, I don't need a calculator. It's 2.25 times 6. 2.25 times 4 is 9. 9 times 6 is 54. So 54 pi is the volume of these two. Oh, wait. We don't... Hold on a second. He pours milk from a gallon jug until it's full. It's the largest number of full milk glasses. So let's cut this in half because this is 2. We actually only want 1. So 27 pi. So now let's set up an equivalency. That's the volume of one of these things. So 27 pi over x, how many gallons, equals 231 cubic inches, this is cubic inches, over 1. Now we cross multiply and figure out how many, how many gallons fits in 1. 231 equals 27 pi x, and then divide both sides by 27 pi. So 231 divided by 27 pi equals what? That's not right. Oh yeah, it is right. 91. No, that seems way too big. It can't be 26. So 231. 27 times pi equals. Then 231 divided by that answer is 2.7. I don't know why that calculator just did that, but okay, so 2.7. No, that's wrong. That's 1 gallon. That doesn't make any sense. Oh, 230. I'm supposed to divide by, I did this wrong. That doesn't make any sense. So the x was supposed to go over here. Made a mistake. That makes more sense. 231. Okay. 27 times pi equals divided by, okay, divided by, oops. Answer divided by 231 equals 0.367. Okay, so one of these is 0.367 gallons. So therefore, how many full glasses can he make from 1 gallon? It's 1 divided by this. So 1 divided by second answer is 2.7. So really only two full glasses. Okay. 54 pi. Yeah, so he can make 2 full glasses, almost 3. Yikes, that took a lot of time. Next one, 3p minus 2 is greater than or equal to 1. What is the least possible value of 3p plus 2? Okay, so 3p is greater than or equal to 3 by adding 2. P is greater than or equal to 1. So p has to be at least 1. So if p is 1, this will equal 1. So 1. P is greater. Oh, no, sorry. 3p plus 2. Excuse me. Plug p in here. So that's 1 times 3 is 3 plus 2 is 5. Excuse me. I almost got confused there. Next. The mass of living organisms in a lake is defined by the biomass of the lake. If the biomass in a lake doubles each year, which of the following graphs could model the biomass? Look, doubling each year. It's like, here's 1, then it's 2, then it's 4, then it's 8. This is like exponential, right? So it's not linear. It's not this weird thing. It's not this. This means there's no change. It's this. The scatter plot. Let's take a picture of this. All right, so we got this guy here. It says the bar above shows renewable energy consumption quadrillions of British thermal units from 2000 to 2010. Okay. What's it? Billions, right? So this is plotted along the x-axis, right? And the renewable energy consumption is here. How many data points would be above the line y equals x? Okay. So that means it's going to be things, y equals x has a slope of 1. So it's anything that has a greater than a slope of 1, meaning if we're plotting 2000, which is this would be my x and this would be my y, right? So we want a slope that's greater than 1, meaning where this guy is larger than this guy, right? Because it's always y over x, rise over run. So we say how many data points would be above? Well, this would be, this would be, this would not be, this would be, this would not be. So 3. Of the following, which approximates the percent decrease in consumption of wood power from 2000 to 2010? So here it's 2.25. And to get the percent decrease, we take the change over the original. The change looks like it drops by 0.25. So 0.25, actually I multiply top and bottom by 4. And I get 1 over 9, which is about 11%. But let's show you why. Boom, and then you move it over 2 places, 11% decrease. Which of the following is true about the data for these 21 days? Okay, standard deviation is what it's talking about. Standard deviation is kind of like, it's kind of like how closely put together the all the data is. When it's smaller, it's closer together. So let's see. So here we got 3, 17, 18, 19, 20, 21. 9, 11, 20. Wait, is it 20 for both? 17, 18, 9, 10, 11, 14, 20. There's less, but, oh, 12, 18, 20. This is a mistake. I think this is supposed to add up to 21 as well. So they must have made a mistake. So, this data is more spread out. You see how this is really clumped together around 79? So this is going to have a smaller standard deviation. So the standard deviation of city B is larger. They're not the same. And we don't need to actually calculate it because that would take too long. So we're good there. Next, in the circle to the left, AB is a diameter. If the length of arc ADB is 8 pi, what is the length of the radius of the circle? So ADB is 8 pi. So 8 pi equals, and then that means it's equal to the circumference times, basically, if it's a diameter, it means the angle is 180 out of 360, which reduces to 1/2. So 1/2, 2 pi r equals 8 pi. 1/2 times 2 is pi. So pi r equals 8 pi. Divide both sides by pi, therefore the radius equals 8. The polynomials are defined above. Which of the following polynomials is divisible by 2x plus 3? Let's see here. Okay, let's factor these. So f of x, so this is where I'm just not sure, and I'm going to try and factor them. That's what I usually say. So f of x, I'm going to divide everything, well, let's factor out a 2. Hold on. It's x cubed. Oh, factor out a 2x. Hold on. 2x times x squared plus 3x plus 2. I think I already get an idea of what's going on here. Yeah, look at this. Look at this. So now, these are the same functions, basically. And if okay, so they're saying they're adding, it's this one, it's b. Let me show you why. So it's the same function in here. So if I were to add f of x to this plus x squared plus 3x plus 2, okay? And then I want it to be divisible by 2x plus 3. Well, this is already, I got a 2x out here. If I throw in a 3 on top of g of x, okay, what happens? Well, now I can factor out by this whole thing. And then it would be x squared plus 3x plus 2 times these guys, 2x plus 3. Therefore, that function would be divisible by this. So that's why it's important to factor, because I would have had no idea unless I just automatically started factoring. Let x and y be numbers such that negative y is less than x is less than y. Okay, which of the following must be true? This is the same as saying x is less than the absolute value of y. Whoops. Because that's the way we split up a inequality with the absolute value. It's x is less than y, x is greater than negative y, where we flip this and turn that negative. So we know this to be true, and I think that's one of the, it's one of the options. So of 1, 2, and 3, 1 is definitely true. All these have 1 though. Now what else? X is less than 0. Or sorry, x is greater than 0. No. Because no. That doesn't mean anything, because x could be -2 and y could be anything. If y is negative, then even if it's negative, positive, whatever, this is always still going to work. So x can still be negative. So I'd say no. So if I know 2 is out, then I know b and d are out. So it's either, so we just got to figure out, is this true? Y is greater than 0. No, we don't know the y is greater. Y could be anything, right? Y could be positive, negative, and this would still be true. So I'm going with 1 only. The relative housing cost for a U.S. city is defined by the ratio to be the ratio average housing cost for the city over national average housing cost. Okay. Population density, relative housing cost. Got it. The scatter plot to the left shows the relative housing cost and the population density. Okay, the line of best fit also shows the equation y equals 0.0125x plus 61. Which of the following best explains how the number 61 in the equation relates to the scatter plot? Okay. So population density of 0 has a relative housing cost of 61% of national average cost. Relative housing cost is $61. No, I'm sorry, 61%. Excuse me, because this is said as expressed as a percentage. So in 2005, wait, hold on. No, this is not by year. So we don't know if it's 2005. Oh, wait, is this all about... Yeah, sorry, this is for 2005. In 2005, the lowest housing cost was about 61% of the highest housing cost. No. No, not out of the highest housing cost, of the national average, even in cities with low population densities. This is probably good. Oh. We're likely at least 61. Yeah, we can't say never below. That's wrong. Because this is just a line of best fit, and these are some data points. So we don't know that, but we say we're likely at least 61% of the national average. All right. 3 more tough problems, and then it's going to get easy. Which of the following is an equivalent form of the function blah, 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 in which minimum value of f appears as a constant or a coefficient? Okay, this is just another way of saying we need vertex form. That tells us the vertex, which is the minimum. So I'm going to FOIL this. Minus 4x plus 6x minus 24. X squared plus 2x minus 24. Now, to get this into vertex form, I'm going to kind of separate this, and I'm going to complete the square. So it's x squared plus 2x. Half of this squared, which is 1. And then this becomes x plus 1 squared. Oh, I have to also subtract 1 out here, right? To compensate for this, minus 25. And so this should be the function we're looking for. X plus 1 squared minus 25 right here. If x is the average of m and 9, average, we just add them together. Y is the average of 2m and 15. And z is the average of 3m and 18. What is the average of x, y, and z in terms of m? Okay. Got to add all these together. Hold on. So we got to do it like this. So we're taking the average of these 3. So it's m plus 9 over 2 plus 2m plus 15 over 2. Oops. Plus 3m plus 18 over 2. And the average of all 3 of these is divided by 3, right? So then let's add, these are the same denominators, so we can add them up. 6m plus 24, 34, 42, right? Over 2 over 3. And then divide this by 2 on the top, so it's 3m plus 21 over 3, which equals m plus 7. Last one, that's difficult. All right, function, this is graphed in the xy plane to the left. If k is a constant, such that f of x equals k, has 3 real solutions. Oh, Got it. Which of the following could be the value of k? All right, so look, that means it's a lot. When you have y equals a constant, it's got to cut this way. It's horizontal. So we need it to equal like -3, where it hits this thing 3 times. 1, 2, 3. Like up here, it hit it once. Down here, maybe twice. So like -3, -3. Yeah. Okay, we're in great shape. 22 minutes left. A partially filled pool contains 600 gallons of water. The hose is turned on, and water flows in at 8 gallons per minute. Okay. How many gallons of water will be in the pool after 70 minutes? Well, 8 gallons in 1 minute, so times 70 gives us 560. 560 plus 600 is 1160. Let me just make sure. 70 minutes, 560. Yeah. The normal cystic blood pressure, blah, 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 is this. According to the model, for every increase in 1 year, how many millimeters of mercury will the normal systolic blood pressure for an adult male increase? Okay, so when it's 0, it's 220 divided by 2, which is 110. When it's 1, right, x is 1, it's 221 divided by 2, which is 110.5. So it goes up by half, essentially. The pes, or Roman measure length, is approximately equal to 11.5. So 1p equals 11.65 inches, called digits. Based on these relationships, 75 digits. Okay, let's change this. How many feet? Okay, got it. So we want to know 75 Roman digits is equal to how many feet? So 75 digits. First, let's convert it to pes. $75 digits to how many pes equals 16 digits to 1 pes. Cross multiply. 75 equals 16x divided by 16. 75 divided by 16. 4.6875. So it's 4.6875 pes. And then we need to convert that to feet. So now let's set up a new equivalency. Pes over x feet equals 1 pes to 11.65 inches, which is how many feet? We just divide that by 12. So 11.65 over 12. What is that? 11.65 over 5 over 12, which equals 0.9708. Okay, now we cross multiply. We get x equals 4.6875 times this. 4.55 feet. Okay, I'm just going to roll with it. I'm not going to scrutinize it too much. I think that's right. There's a lot of calculations there. Next, study bat migration. 240 male bats and 160 female have been tagged. If 100 more female are tagged, how many more male bats must be tagged so that 3/5 of the total population in the study are male? So 240 plus X, number more that they have to tag, over 240, 400, 500 total now, right? Plus X equals 3 over 5. Cross multiply, we get 5 times 240 is 1,000 plus 2, 1,200 plus 5x equals 1,500 plus 3x. Subtract 3x, subtract 3x. We get, let's write it up here, 2x, and then I'm going to subtract 1,200, subtract 1,200. 2x equals 300, therefore x equals 150. Okay, and that seems to make sense, right? So then the males would be 390 out of 650 total, which is 39 out of 65, which is divided by 13 is 3 over 5. Yeah, so 150. The dynamic pressure Q generated by fluid moving with velocity V can be found using that where N is constant. A canonical engineer uses the formula to find the dynamic pressure of a fluid. Velocity V, fluid moving velocity V in the same fluid with velocity 1.5 V. What is the ratio of the dynamic pressure of the faster fluid to the slower fluid? Okay. So here's the faster one. It's 1/2 NV squared. Here's the other one. 1/2 N 1.5. Oops. So everything else stays the same. So we don't care about any of this and this. All that happens is this is V squared to, this becomes 2.25 V squared. So it's 2.25 to 1. Right? And then faster to slower, so it's 2.25. We could also represent it as 9 to 1, right? I'm sorry, 9 to 4, but I think this is fine. Okay, next. Wait, hold on. Let me go back to this, see if it wants it as a fraction. No. No, we're good. In the figure to the left, circle O is a center, 0, O in radius 10. If the length of arc AB is between 5 and 6. Hold on here. We got plenty of time. Okay. So it has a radius of 10. If the length of AB is between 5 and 6, 5 to 6 or 5, let's write it like this. Okay, it's this length here. What is one possible integer value of x? Okay, well, look, here's the deal. X over 360 times the circumference, which is 2 times pi times r, which is 10. They're saying it's greater than or equal to 5. Let's just leave it at that. It's greater than 5, less than 6. But what I'm going to do is whatever value I get here, I'm just going to go up to the closest integer, and that's going to be correct. So this simplifies to 20 pi x over 360. It's greater than or equal to 5. Multiply both sides by 5. 20 pi x is greater than or equal to 1,500 plus 300 is 1,800. Divided by 20 pi, divided by 20 pi. So 1,800, hold on, divided by, let's do it like this because I've seen mistakes happen on this calculator. It's about 60, so it should be about 30 is the answer. So that's close, that makes me feel good. So 29, I'd say 29 degrees. Next. The stock price of one share of a certain company is worth $360 today. Stock analyst believes will lose 28% each week for the next 3 weeks. Okay. They use this to model the value of V after 2 weeks. What value should the analyst use for R? So if it's losing 28%, it shouldn't be 0.28. It should be the other side of 0.28, which is 0.72. Okay. So that you always want, because every time you take 28% away, you're left with 72%. So 0.72 is the value that you want. Next, to the nearest dollar, what does the analyst believe the value of the stock will be at the end of 3 weeks? So let's just use the formula. We've got V equals 360 times 0.72 to the third power, right? 0.72 to the 134.37. Oh, nearest dollar. Sorry, 134. And that feels good to me. That sounds about right, right? $28. That means we're losing. I mean, 28%. So we're losing like 30, 90. We're losing about $100 the first week, so $260. Then we're losing about $60, $78 the next week, so like $180 something. And then we're losing about $50. It's roughly right. Okay, I think, let's see. I can't remember which problems I flagged, so in this case, it's okay. I'm just going to go for it. I've got 11 minutes left, but let's just see if I got anything wrong, and if I did, it's cool. I'll go over it. Let's see what's up here. All right, let's review this section. 3 wrong. That's huge. Okay, well, maybe I should have checked. Let's go. Let's kind of flip through to all these. Oops. Which ones did I get wrong? Okay, I got this one wrong. Okay, let's look at this. Let's just resolve it here. So Raul worked 11 hours more than Angelica, and then combined they did a total of 59, right? So I plugged in this. How many hours did Angelica work? A plus 11 equals 59. So 2A subtract 11 equals 48. A equals 24. Oh, I don't know what I did. Oh, you know what? Maybe I added 11. I don't know. I must have made some really silly mistake. Okay, that's funny. Next, let's go through these ones. Okay, here we go. 2. Let's see. This one I thought I had pretty well. Okay, let's see. So in what's the largest number of full milk glasses? Okay, so he pours from a gallon jug into each glass until it's full. Okay, so an internal diameter of 3, so the radius is 1.5, right? And then we've got 6 inches. You can pour. What is the largest number of full milk glasses? Okay, so let's do it like this. You can pour from 1 gallon. So first, let's calculate the volume, which is 6 times pi r squared. So 6 times pi times 1.5 squared equals. So that's the volume in cubic inches of 1. So I'll just divide it by 231. Okay, so each one is a 0.184 gallons. So I think, yeah, I didn't get that. 0.18. I don't know what I did. All right, so 0.184 gallons, and then 1 divided by that should give me my answer. So it's 5. Huh. Not sure what I did on... I'm not sure what I did there. Okay. Very interesting. So that's another kind of really bizarre mistake. I usually don't make things like that. Okay, then let's go to the next one. Next. Okay, this one. Oh. Ooh, wait a minute. Y is greater than 0. 3. Absolute value of x is less than y. Oh, yeah. Whoa, what was I thinking? That does have to be true. Y does have to be positive because if we're taking the absolute value, it has to be less. This can't be negative because this is negative. This will never be smaller. So 3 is also true. Wow. All right, that was just a total error on my part. So What can I say? You know, sometimes, like I said, these mistakes will happen, and hopefully that's part of what you like about watching me in particular, that I'm doing these legitimately and for real. I think if I would have slowed down a bit here, I would have recognized that I just totally made a slip of my mind. Anytime absolute value is, you know, you're always getting a positive, so that by definition means y can't be negative. All right, let's go on to the questions here. All right, you usually write stuff out for our benefit. On the actual SAT, what types of problems do you use purely? Oh, all right, so Adam, that's a really good question. Like, how many types of problems do I use pure math for, pure mental math? So I'm really, really, really confident with my mental math. So I would actually, when I really took the SAT, I did a lot in my head. And anytime when we're getting into decimals and decimal division and stuff like that, then I'm using a calculator. But when we're talking about whole numbers, I rely on it a lot. But that's a very personal question. It just depends on how many mistakes you're making with mental math. So I would use that as your gauge. Do I not get bored? As I'm starting to do these more and more, it's not as fun. No, the first few times I was doing it was really fun, but yeah, it starts to get a little boring. Okay, how do you know whether the median value you're solving for is based on the number set or the middle of the overall operation? Is that for the standard deviation question? If it is, we didn't need to know I mean, for the standard deviation, we didn't need to know the middle. I wonder which question you're asking for. So I'm not sure, but okay. Number 21, you have a different graph than the book. Oh, really? Oh, so yeah, so it must be a mistake. Number 25 is confusing. All right, I'm going to go over number 25 for you. Okay. Yeah, this one's super confusing. Okay, look, at the bottom, at the end of the, let me slow down a little bit. My first thing was, when I'm stuck and I don't know what to do, I always factor. So in this case, what can I factor out of that top one? Well, I can pull out a 2x out of everything, right? So then I have x squared plus 3x plus 2. And then when I did that, I realized, oh, wait a minute. These two are pretty identical. Okay. So now I'm like, all right, well, what are they talking about? They're talking about this other function where we're dealing with sums of f of x and g of x. And we want it to be divisible by 2x plus 3, meaning we want 2x plus 3 to be a factor. Now, if I just straight up add these together, I mean, I don't know, maybe it would be a factor anyways, right? If I just added this plus this. But if we want to look for a solution where it's really clear that 2x plus 3 is going to be a factor, well, look, right now, if I put a 1 out here, and then I add these two together, I'll get 2x, x squared, plus 2, plus 1 times x squared plus 3x plus 2. Now this alone, since I have a 2x and a 1 out here multiplying the same polynomial, I could factor out 2x plus 1, oops, times x squared plus 3x plus 2. Okay? So this function, when I add f of x plus g of x together, it would be divisible by 2x plus 1. But now, if I multiply g of x, the second function, by 3, that means now I can factor out a 2x plus 3, which means that f of x plus 3g of x is actually divisible by 2x plus 3 for sure. So that's what I saw when I made this first connection, that these are all the same, or almost the same. They have the same polynomial. I was like, oh, I'll just multiply the bottom one by 3. So that's how you do that one. Okay. Okay, guys, hopefully all that made sense, and you're getting closer to being ready for the SAT on Saturday. Oh, hold on, I got a new question here. Why is it not C for number 5? Let's take a look here. Oh, 25. Because, all right, so I've already factored out I've already got a 2x in front of this, right? If I did 2 times f of x, so let me show you what would happen there. Whoops. If I did 2 times f of x, so this is already with 3, right? And then I'm multiplying this top one by 2, then this becomes 4. then this would be factorable by 4, or divisible by 4x plus 3. Right? Because originally when we factored out, we got a 2x. That's why. Okay, so hopefully that made sense. Thank you guys so much for joining. That was really fun. We're going to do one more tomorrow, but tomorrow is going to be an additional amount of, excuse me, I'm losing my voice, an additional amount of tips and tricks from a really cool presentation that I've created. So I'm going to give that first, then we'll dive into the practice problems. It's also going to talk about what to do the day of the test on Saturday to make sure to get your mind in that right spot for optimal performance. If you like this video, please click that like button right now. It really helps me out. And if you want to see more, definitely click the subscribe button. Again, if you want to take a look at my SAT video course, you can do that by clicking the link below and buying one of my courses. I got a bunch of practice problems and more video explanations that you can use. And it's a really good discount if you buy it down below, 75% off, so only 50 bucks. Thank you guys so much for joining, and I'll see you guys all back here tomorrow at 10:30 a.m. for the final study session. Take it easy.